Okay, welcome back everyone. This is the first solved example for projectiles, and projectiles generally fall into three types of problems. So the first type is what we call horizontal launch, or sometimes we say that this is a cliff problem. So here's why. A cannon fires a cannonball with a speed of 30 meters per second horizontally from a height of 125 meters. We want to find the time of flight, so how long is it in the air. We want to find the horizontal distance the cannonball travels before hitting the ground, and we want to find the velocity of the cannonball the instant before it hits the ground. So we're going to try to follow roughly the four-step method, and the first step is to draw a picture and identify everything we know. Okay, so here's the cannonball basically being fired. I know it looks like a baseball, whatever. Not an artist, and it's being fired with a speed of 30 meters per second horizontally, and we know that that is some type of initial speed, so it's v initial, and because this is all horizontal, that's vx initial. Now later on we'll talk about firing at an angle, which makes things interesting. We also know that we have the ground here, and we have a height of 125 meters. So what this tells us is a couple of things. We could say that y initial is 125 meters up, and we can say that y final somewhere is going to be 0 meters, or we could simply say that delta y, which is y final minus y initial, is going to be negative 125 meters. So any of those are okay. And we know that the path it takes is going to be a parabola, and we know this because of our equations of motion. We have a t squared in there, so we have a parabola like this. Okay, and we want to find out where it hits and the time of flight and what the velocity is the instant before it hits the ground. And I'm recording this right before school is about to end, so I may take a bit of a break when the bell rings. Okay, so this is the first part. We want to find the time of flight. Okay, now the general idea for most projectile problems is that you will be able to almost completely solve all of them if you simply write down these two equations. Delta x equals and delta y equals. Of course, you have to finish the rest of the equation, but writing the two distance equations is usually enough to completely solve any projectile problem. And I'll show you that on this example and the other two. So delta x, remember, is vx initial times t, and delta y is vy initial times t plus 1/2 gt squared. And if these look completely unfamiliar, you should go review the previous video on projectiles. Okay, now one other known that we have here is we actually know what vy initial is. Because it's launched horizontally, vy initial is 0. So that's nice because that automatically gets rid of this term. So let's see what we have. For the first equation, we don't know delta x. That's actually one of the things that we're trying to solve for, how far it goes horizontally. Okay, but we can still write that equation. Delta x is equal to vx initial, which is 30, times time. But we don't know time. So this equation, we're kind of out of luck because we have two unknowns. And if this was the only equation you used, you'd be really sad because you couldn't solve it. So that's why we have the second equation. Delta y equals 1/2 gt squared. And we know that delta y is negative 125 meters. So that's going to be equal to 1/2 times g, which is negative 9.8 meters per second squared, times t squared. Okay, so here's how this works. We have negative signs on each side. They can cancel out, and I have 125 meters divided by 4.9 meters per second squared is equal to t squared. And the 4.9 is just 1/2 times 9.8. So 125 divided by 4.9 gives us t squared is equal to 25.5, and what are the units? Well, meters divided by meters per second squared is the same thing as meters times seconds squared per meter. Guess what? We have seconds squared. And to solve that for t, take the square root. So t is about 5.05 seconds. Okay, so that is the first part, finding the time. The second part, finding the horizontal distance that the projectile travels, well, that's actually pretty easy. We just take this time and we plug it back into our delta x equation. So delta x is 30 meters per second times 5.05 seconds. And look at that, seconds cancel, and it's about 153 meters. So there is our horizontal distance traveled. Now the last part is a little bit trickier. To remind you of what this is asking, let's go back up, and we're looking at the velocity of the cannonball the instant before it hits the ground. So something that we will talk about, if we haven't already, in class, is that velocity is always tangent to a path. So right before it hits the ground, the velocity is actually kind of down at an angle like this. And in just a moment, I'm going to take a break now because the bell's going to ring, but I'll come back and we'll talk about how to determine the velocity. While you're waiting, you might want to think about, what do I do? Okay, did you think about it? For me it was like 5 minutes, but for you it was more like 3 seconds. So here's what we do. The velocity is actually going down at an angle like this. This is what we would call v final. But in order to find v final, we need to know its components. We need to know vx final, and we need to know vy final. Now if you look back at the table, it turns out that we have equations for these. Vx final is equal to Vx initial. And if you don't remember that, look back at the table. Here, I'll flip back. There it is. And Vx final is equal to Vx initial. So we have that Vx final is equal to what we started with, or 30. So that's 30. Now Vy final we can use an equation for as well. So Vy final is Vy initial plus GT. The problem is we don't know what Vy initial is. Oh wait, yes we do. It's 0. Gravity is negative 9.8 meters per second squared, and the time is about 5.05 seconds. So those cancel to give us Vy final of negative 49.5 meters per second. So this is negative 49.5. Now if you look at our diagram, hopefully this makes sense, part C by the way, that the x velocity is positive because it's to the right, and the y velocity is negative because it's down. Okay, so now we know how to combine these and get the hypotenuse by now. Okay, and so v final squared is vx final squared plus vy final squared. So that means that v final is equal to about 57.9 meters per second. Pause and try this on your calculator if you don't believe me. I'm just doing 30 squared plus 49.5 squared. And then to find the angle is the inverse tangent of 49.5 and 30. And those units cancel, so I'm not too worried about that. And that angle is 58.8 degrees, but it's negative because it's below the x-axis. So this is at negative 58.8 degrees. So that's what we would say for the final velocity, the instant before it hits the ground. Now after it hits the ground, obviously it's not traveling at that speed. But this is one example of how we can use our projectile table to start solving problems.